As I mentioned, probably the single most important topic. I can edit that out. Oh, I didn't realize I could use those other buttons on my clicker. By the way, I also have a laser. Get it up.
Where is it?
There you go. Anyways, yeah, most important topics that we're going to talk about. But before we get started, on your calculator, hit the mode button, M-O-D-E, in the top row. A lot of information going on in that bad boy. However, there is some crucial stuff that you need to have set properly. On the, depending on your calculator, there's a line that says float, 0, 1, 2, make sure float is highlighted. Float? Yeah, you got the black box around it. Okay? Then, most importantly, the one below that where it says radians in degrees. Degrees needs to be highlighted. Mouse down, go over to it and hit enter.
I can only do one of those.
Correct, just degrees. Okay, that's the mode that the calculator is operating in. Now, it is very important with what we're going to do today that your calculator always be in radians. Early on, I'm going to remind you on a regular basis, check to make sure you're in degrees. The reason being, if you're in the other mode, you'll still get answers. They'll just be wrong. Now, here's a great prank to play on your friend. When your friend leaves their calculator laying around, just jump back into that mode button and put it in radians. That's a good one. Then they get their whole quiz wrong, and that's a good time. Then you can post about it on Instagram and Snapchat, make a video, a dance to it. You know, write a song. I changed my friend's calculator and they failed geometry, and then some cool dance moves with like pushing buttons and stuff. And then go from there. Okay, we good to go? Excellent. Trigonometry involves right triangles. Now, everything that we're going to do for the first part of this chapter is going to be what's called right triangle trig. It's called right triangle trig because it involves right triangles. But that's very limiting. In other words, not every triangle in the world is a right triangle. We want to be able to work with all triangles, and we'll get that later, but we need to crawl before we run here. So we're going to come up with this general labeling system for a triangle. Every triangle you get is not going to be called ABC. However, the way you label the triangle is the following. Whatever vertex is labeled as A, capital A, then lowercase a is across the triangle from it. Uppercase B is across from lowercase b. Uppercase C is across from lowercase c. Uppercase letters, remember, are points, and therefore those are the vertices. Lowercase letters are lengths, so they are the side lengths. So just for giggles, in your notes, I know you've already done this, but change it. Change the triangle to XYZ and label it. So if you already got A, B, and C in there, erase them and put in X, Y, and Z and make sure you put them in the right locations. The single most common mistake, not the single, the common mistakes that people make in trig are, number one, being in the wrong mode, and number two, labeling their triangles incorrectly.
Wait, what do you want us to do?
Draw a triangle in your notes, a right triangle in your notes, and label it X, Y, Z. No. Label it X, Y, Z, and then label it accordingly so I know what you're doing. Oh, good. here we go. There are three trig functions that we're going to deal with, and these are functions. What do I mean by functions? A function is a mathematical operation. Addition is a function. You take two numbers, you do some weird math stuff, it spits out a new number. That's a function. Multiplication, division, square roots, all those things are types of functions. They take a number, they do something to it, it spits out a new number. There are actually 6 trig functions. We're only going to deal with 3 of them. Sine, cosine, and tangent. They are abbreviated sin, cos, tan. When you're done writing, find those buttons on your calculator. They're pretty hard to miss. Those are abbreviations. Please don't call it sin, cos, and tan. People will make fun of you and lock you in a locker. Sine, cosine, and tangent. Okay, we good to go?
Oh.
Yeah. Some of you maybe even never noticed the sine, cosine, and tangent buttons because you've never used them before. It's just like the comma button. You didn't even realize there was a comma button until you started coding. Now, you can press those buttons all you want. You're not going to understand what you're doing. So, just for giggles, well, I think we do this. Hold on. Just let's baby steps first. Hold on. So, we can talk all day long about how these trig functions work and what they do. For instance, on your calculator, let's just check to make sure we're all on the same page. Hit the sign button, hit 37, and then hit enter.
Wait.
No. It's probably not a bad habit to get into to close those parentheses, but you don't have to. So you should get 0.6018, yada, yada, yada. We're all good, yes?
Yeah.
Now, you have no idea where that number came from. And it's like making hot dogs. You probably don't want to know what's in a hot dog.
Yeah.
Yeah, you just move forward with that and not ask too many questions. The same is true with trig. Now, here's the old man moment. Many of you have taken the pass to the washroom, and you've seen this side of the pass, but I'm sure that many of you didn't look at it very carefully. Actually, it's upside down. It's this way. So this is a desktop. This is an old desktop for desks that we used to have here at Prospect. This was particularly a desk that was used in a math classroom because one side of this is graph paper, both polar and rectangular. Who cares? The other side of this, however, is what's called a trig table. Okay, so I just gave you the sine of 37, right? So I look here and I say, all right, let's see, common logs, sine of 37 is smack dab where the I is. Oh wait, here's 37. What'd you get? 0.6018?
Yes.
Yep, there you go. So we used to have to look these things up. With your technology, however, you can get all kinds of different things. Using this chart, the way we used to do it, you could only get the trig values of whole numbers. Okay, but you, however, can do, let's say, the tangent of 37.159, if you want to get real picky. So this is a classic, back in my day, and you don't have to worry about it, except when you have to go to the bathroom. All right. By definition, all these trig functions are just ratios. That's it. Don't make it more complicated than it has to be. They're ratios between the sides of a triangle. So these definitions on the screen are all based around angle A. However, we're not just going to work with angle A, we're going to work with angle B, and angle X, and angle Y, and angle Z, but you get the general idea. Okay. Now, let's explain the terminology here. From angle A, there are 3 sides that we're going to worry about. And those three sides are based on the angle. So for angle A, the three sides, we'll start with the easy one. One of them is the hypotenuse. Which side's the hypotenuse? C. Okay, and that's always going to be the hypotenuse. It's the longest side, it's the side opposite the right angle. The other two sides, the easy one is the opposite side. That's the side across the angle. So from the angle I come across, and it's also the one that if you labeled your triangle correctly, is the same letter, just lowercase. Okay, so that's opposite. This is hypotenuse. Hypotenuse. And then the other side is the adjacent angle. Whoops, ADJ, adjacent. What does adjacent mean? Next to. Sometimes where you get problems is if I just give you the angle A and I say, well, which side is adjacent, you would say, well, how do I know if it's B or C? Great question. The answer is, it can't be C, because C is the hypotenuse. Okay, so now we can identify the sides in relationship to the angles. The trig definitions then are just setting up ratios between those given sides. Okay, so the sine of any angle is going to be the length of the opposite side over the length of the hypotenuse. The cosine of any angle is going to be the length of the adjacent side, not the hypotenuse, because it's over the hypotenuse. And the tangent is the length of the opposite side over the length of the adjacent side. What you might find more helpful, and you may have heard this before from somebody, SOHCAHTOA. Anybody ever heard that before? Okay, you will hear it a lot. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Okay, just for giggles, let's try this. Do you have this, by the way? We're good? Okay, clean that. Let's change the pen color to blue. Let's do this again, except for angle B. Okay. All of that screen is based on angle A. Let's do it for angle B. So with respect to angle B, Liam, which side is the hypotenuse? That's what I'm asking you. Which side is the hypotenuse? C. Good. Notice that didn't change. It's always the hypotenuse. Hypotenuse. Okay? Liam, which side is the opposite side?
Angle B?
Side B, you mean? From angle B, yes.
Yeah, side B.
Side B. And by process of elimination, A would be the adjacent side. So, Liam, what's the sine of angle B? Is he right? Is he right? Yeah. Opposite over hypotenuse. Liam, what's the cosine of B? A over C. Bring it home, Liam. Tangent of B. Say again? B over A. Okay. So some of you are going to go home and try to memorize these guys. It will do you no good. As soon as I give you a triangle that's labeled differently, that information goes right out the window. But SOHCAHTOA will get you very far. That's what you want to know. And you'll get better at it through practice. I'm good? Okay. Okay, now notice my triangle's labeled differently. So let's do this. TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. It's a mnemonic to remember the trig stuff. Ava, what's the sine of A? Four over, perfect, 4 over 5. What's the cosine of A? Outstanding. Wrap it up. What's the tangent of A? Or as my grandfather would say, 4 turds. Very good. Okay. Any problems with that? I'll write it down. Hold on. Ava, give me that again. Sine was what?
4 over 5.
Good. Cosine was
3 over 5.
hot diggity. And tangent
4 over
or 4 turds. Very good. Okay. Excellent. Any questions for Ava on that? Does that seem fairly easy? Jackson.
Was the final one tan? Like the 4 over 3?
I'm sorry, what'd you say?
Was 4 over 3 the tan? And
The what? What? Tangent, very good. Yes, it was. 4 over 3 is a tangent. Okay? We good so far? Excellent. Lana, what's the... Hold on, I'll get back to you in a second. Yes, Riley.
I'm really confused. Like, on like how you get the numbers.
Hold on, I have somebody that can help. Ava, how'd you get... Don't look at me like that. How'd you get those numbers?
I looked at my notes.
She went back to this,
Yeah.
and she looked at the sine of any angle is the opposite side over the hypotenuse side. So she looked at the angle A and said, from the angle A, which side is opposite it? It's 4, because it goes across the triangle. Which side is the hypotenuse? That's the longest leg, has got to be 5. And then you just set up a ratio, done.
And then
And then cosine is adjacent side, which has got to be 3, over the hypotenuse, which is 5.
and then if it was like that, like you would just do the same thing.
Well, hold on, we're getting there. Hold on. Lana, what's the sine? Shh. What's the sine of P? Over. Excellent. What's the cosine of P? 4 over 5. Outstanding. What's the tangent of P? Excellent. Does that make sense for the rest of you that are confused? Don't overthink this. You're just setting up ratios. The problem is you got to remember this or the SOHCAHTOA. But you'll get better at it through time. You'll notice, and the question at the bottom is a giveaway, I didn't ask you about angle E. We try, whenever possible, to not deal with the right angle. Okay? Why? Well, I'll ask Freya. What's the tangent of angle E? Excellent answer. It doesn't make any sense, right? Because we went opposite over adjacent. Well, which adjacent side do you pick? See what I'm saying? What's, well, all right, hold on, just for giggles. Type in the tangent of 90 degrees in your calculator. Tangent of 90 on your calculator. What do you get? Error, okay. Let's try the sine of 90. 1. How about the cosine of 90? Huh. Why would the sine of 90 degrees be equal to 1? Liam?
Because the opposite side is the hypotenuse.
Correct. In this particular case, the opposite side is 5, the hypotenuse is 5, and sure enough, 5 over 5 is 1. Which one gave us an error? Tangent. Why does the tangent give us an error? We need opposite over adjacent, and the calculator doesn't know, are you talking about 4 or are you talking about 3? So it just gives up and tells you it's an error. My point being, we're not going to be working with the right angle very often. In fact, not at all. So don't get in the habit of diving into that and looking for 90s, because we're not going to do that. We'll deal with the two acute angles, but not the 90-degree angle. Question?
So if the answer's on the right, was it just using P?
Correct. Okay. Anybody still confused? We're good. Again, KISS method. Set up a ratio. We've talked about the KISS method, right?
Yeah.
Okay, good. Don't overthink it, because it's going to get a little weirder. So as long as you can set up these ratios, you'll be fine. All right, do these three just to make sure we're all on the same page. We already checked it, but go ahead. Oh, you know what? Hold on, let's have some fun. Juliana, could you put your calculator back in radians? And then do these three things? And then tell me the numbers that you get? While you guys are leaving yours in degrees, go ahead and type in the cosine of 41, tangent of 74, and the sine of 2. Question?
Yeah, what's KISS mean?
Keep it simple, stupid. Okay, give me the cosine of 41, Juliana.
-0.9873.
Okay, we'll stop there. How about the tangent of 74?
-5.737.
And the sine of 2?
0.909.
And that's why that would be such a funny joke. She got the answers. They're just wrong. Your answers are different, yes?
Yes.
They better be. So again, try it even better. Try it on somebody in like Kanupke's class. Maybe if we're careful about it, we can get another half strike out of one of Kanupke. Kanupke gets so rattled because all her kids are getting things wrong that she does the answer key wrong, and next thing you know, boom, we got donuts. Okay. So we're playing the long game here, kids. Find some Kanupke geometry students, mess with their calculators. Kanupke gets flustered. She's working on the answer keys. She's screwed. This is going to take some time, but you know where we're going to end up? With donuts, correct. All right, let's move on. Before I forget, Juliana, put your calculator back. All right, beautiful. All right, so we're all operating with the same tools now, and that is a calculator set in degrees mode, and we want to start solving problems. Setting up ratios is great, but I want to start solving problems so I can do things like calculate the height of a flagpole, figure out how tall the building is at Prospect, how high is the top of the press box of the football field, those kinds of more interesting problems than just what's the tangent of 74 degrees. So we need to start practicing how to apply that stuff to solve for the angle measures. All right, so just some plain old triangle. Number one, I see that it's a right triangle, so I'm good to go. Because again, this is only right triangle trig. Number two, I'm going to take you through this example, and I'm going to share with you the self-talk that I use in order to solve these problems. And if you want to use it, great. If you have some other method that works for you, great. But it involves 2 steps. Set up a trig equation, solve the trig equation. Okay? So let's solve for x first. Here's what I'm looking at. I got an angle. I know one side length. I'm looking for the other side length. So I ask myself, self, what's the... Hi. Oh, thank you very much. Do we... Oh, I see it. Got it. I figured it out. Thank you. They don't trust us to keep all $500. I have to send in folders every once in a while. It's like we're going to go out gambling with the money or anything.
What?
Just think if I took that money and went to the boat, I could double or triple our money.
Well, you could lose it all.
Well, there is that side to it. Yes, I could lose it all, but
Say nobody donated.
I got a bunch of bums in my second block class. They didn't donate anything. But we could also be like, we donated $10,000.
That's,
Just because I'm a math guy and I'm pretty good at blackjack.
isn't that a school?
I'm good at blackjack.
I don't know.
Yeah.
I don't know what's
Mr. Reed, let's play blackjack. Let's actually
Yeah,
one class, let's play blackjack. I'll bet money.
What?
Let's play blackjack one class.
With that money?
No,
I
just
can't take you
for our
guys
own
to the
money.
casino. You can't
No, we
get
can play it here.
But who are we gonna get to pay us if we win? Oh, you're saying we learn how to play blackjack?
Yeah, I know how to play.
But not everybody does. Hey, all right, stop. I got stuff to do. Hold on.
We'll teach
No,
everybody.
run out of time. Simply. Okay, so I ask myself, what sides do I know? What side am I looking for? And what's the relationship between those sides? So I know that the 3 is the hypotenuse. Got that. Is the x the opposite or the adjacent? It's the opposite side. So then I ask myself, what function, what trig function uses opposite and hypotenuse? And you would tell me the what? The what? What's it called? The sine function. Then I set up an equation. The sine of the angle is equal to the side opposite over the over the hypotenuse. I don't know what I just did there. Why did I put a 4 in there? Any questions on how I set that up? Okay. We're good? I'm not going anywhere.
What?
I'm dealing with the angle 40 degrees because I know that's my given information. So now I treat that as like my angle A. I'm looking for x. I know 3. 3 is the hypotenuse. X is the opposite side. So then I go back to that screen that had my functions, or I remember this.
Is that so complicated?
Which one of those involves the opposite and the hypotenuse? The sine. So I set up my equation. Then I solve. Okay, now let's talk about a couple logistics here. You'll notice that when I multiply both sides by 3, I put the 3 in front of the sine. The reason I did that is I don't want that 3 to get mixed in with the 40. In other words, if you type in sine of 40 times 3 on your calculator, and you're not careful with parentheses, you're going to get a wrong answer. Therefore, I put it out in front so I don't have to worry about it. So on your calculators, tell me what 3 times the sine of 40 is. By the way, before, don't say anything else. Will it be bigger or smaller than 3? Smaller, good. And what is the answer? 1.9283?
Yeah.
83, so remember 3 decimal places. Done. Okay. Now, before you do anything else, store that number into x.
Wait. What? Why you did that? Oh.
Just say stow x. Done.
X.
How do you do that?
What? Popping noise?
Like alpha X?
No. What? Alpha x with the x up on the top. There's my trick. Okay, so I gotta pick up the pace a little bit. 11:20, right?
Yeah.
Okay, I'm gonna go faster. So Now I need to solve for y. There's a couple different ways you can do that, because notice now I have a right triangle and I know two of the sides. How can I solve for y? Bingo, Pythagorean theorem. But if you use Pythagorean theorem with 1.928, you're going to get an answer that's not accurate. That's why I had you store it. But I would not recommend that approach to it. Okay? We're going to use trig. You might be sitting there saying to yourself, Self, why do I need this? I can just use Pythagorean theorem. Notice we started the problem only knowing one side. Okay, I'm going to change colors here. How do I solve for y? Well, I go back through the same thing. I know 40, I know 3, and I know that y is the adjacent side. Which trig function uses the adjacent and the hypotenuse? Cosine. What would my equation be? The cosine of what?
Y?
No.
Oh, 40?
40 is equal to? Y over 3. Perfect. Solve that quickly, please, and tell me what y is. 2.298. Beautiful.
Wait.
3 times the cosine of 40.
Oh, you're 2.23.
We're going to get through this together, you and I. We can do this. That's why I'm dancing around so much. Hi.
And you remember that
Any questions? Okay, so let's look at another example where things change a little bit. But pretty much this system is what you're going to do over and over and over again. Things get a little bit more complicated from an algebra standpoint, not from a trig standpoint. This process that we just did for these two sides is what we're going to use over and over again. Okay, so let me erase some of this stuff here. Yeah, oh, I didn't show you a picture yet. Hold on. Okay. Before we go any further, we're going to deal with the 15.5 degree angle. Which side is the hypotenuse? S, as in salamander. Good. Which side is opposite? R. By the way, what's a pirate's favorite letter?
R.
No, the C.
So it's R.
And obviously 35 is adjacent. Okay? Now, the reason this is a little different is because we're solving for the hypotenuse in the previous one. We had the hypotenuse. So I'm going to solve for R first. I got this angle. I got this opposite side. I got this adjacent side. Which trig function is that? Tangent. Very good, Alex. Thank you. The tangent of 15.5 is equal to R over 35. Okay. Solve for R quickly, please, so we can move on. $9.706. Okay, good. Can somebody confirm? Good. Okay, now the weird one. Solving for S. Still have the angle. Still have the adjacent side. Now I need the hypotenuse. Which function uses adjacent and hypotenuse? Cosine. Cosine of 15.5 is equal to 35 over S. This is going to cause some problems for people. So I'm going to give you a nice, easy way to solve the problem without spending 20 minutes talking about algebra. When your unknown is on the denominator, or in the denominator, I should say, we're going to do something called the switcheroo. I know. It's not that amazing. The switcheroo takes the denominator and switches it with the value on the other side. Hence the term switcheroo. This becomes the S is equal to 35 over the cosine of 15.5. Okay? The switcheroo. You switch the denominator with the other side. Type that into your calculator. Make sure you can get the correct answer.
When's like a time it would do that again?
When your unknown is in the denominator.
Okay. Oh, the 3 over Wait, Mr.
Yeah.
I'm going to ask you to repeat at one time.
Sure. All right, so everybody stop talking. This is important.
So I'm putting it 36.32.
What part of stop talking don't you understand? Good. Now, to confirm or to reiterate what happened there is I set up the trig equation, and I'm assuming we're all good setting up that trig equation, yes? But what I noticed as soon as I set up the trig equation is that my unknown S is in the denominator. You can solve that by cross-multiplying if you want. Multiply both sides by S, then divide by the cosine of 15. I'm just giving you a way to cut out the middleman. You can cut out the middleman by doing the switcheroo. And the switcheroo takes the denominator and switches it with the other side. So the denominator and the other side switch spots. And then you pick up your handy dandy calculator, boop, 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 you're done. Okay. Now, the other thing that when people get introduced to trig that they start doing quite frequently is, let's go back to this example here. They do something silly like, I'm going to divide both sides by sine. Okay? So this and this. That is wrong on so many levels. If anywhere in any of this stuff you have just these 3 letters sitting there, you did something wrong. You have to take the sine of something. You have to take the sine of an angle. Okay, so that's why when your calculator, when you type in sine, it automatically puts a parentheses there. The calculator is saying to you, hey, doofus, put a number in there. I can't just do the sine of nothing. I need something else. You should be thinking that same way. Okay? Questions so far? 4 minutes. All right. Now, I'm going to stop here because there's a whole nother part of trig we haven't covered yet, and that is, how do we get the angle measures? So we had this triangle APE, aardvark, puma, elephant earlier, and we worked with the ratios. Everything was peachy keen, but I'd like to know how big angle P is. We're going to solve for that later. Now, on Wednesday, when you're working on some of this homework problems, when you get to these problems where you're looking for the angle measure, you're going to be stuck a little bit. Okay? You're not going to know how to do it. That's okay. We'll pick up where we left off on that material when I come back. That starts something even uglier. Look at your calculators. Find the sign button on your calculator. And look above that button. You will see something that says sine -1. That's what's called an inverse function. So even though we're not going to go into this, I'm going to talk a little bit about inverse functions to save some time. An inverse function undoes what another function already did. So for instance, what's the inverse function of addition? Subtraction. What's the inverse function of multiplication? Division. What's the inverse function of squaring something? Square rooting. You get the idea, right?
Yep.
Okay, so this inverse function undoes what we've already done. So let's go back to this slide. Let's go back here. Here we go. Real quick, I'm almost done. Bear with me. This isn't the right value. Somebody take the cosine of 41 and tell me what the answer is, please. Wait, don't start packing up. We're not done yet.
0.755.
Okay? I know that there's an angle of 41 degrees that when I take the cosine of it, I get 0.755. Now on your calculators, do second cosine, so that gets you up into the inverse of 0.755. What do you get for an answer? You get really close to 41, right? Okay. That's what the inverse trig function is doing. We said that if you take the cosine of 41, you get 0.755. What I just had you do is what's called the inverse function. We'll talk more about that on Friday. Questions? Beautiful.